afternoon, everyone. I am Erawati Ravindra Kadam from IIT Delhi. My research topic is centered around the construction supply chain, specifically focusing on the green supply chain. As many studies focus on the conventional studies focus on the efficiency of supply chain, but I am looking into the environmental aspects of the supply chains for the construction industry. These are my contents. Now moving towards the introduction, we know that every construction projects, not in construction projects, every industry began with the supply chain, which contain the flow of material, information, and product from supplier to the client. So these stages can cause many environmental impact and need many resources. So this graph shows that many industry supply chain can cause the environmental impact from the upstream, direct and downstream of the supply chain. So when we look into the construction industry, specifically for the construction industry, material used in the construction already accounts for the 9% of the total CO2 emissions. Now we are moving towards the sustainability. World is moving towards the sustainability. New regulation, new policies are there for the sustainable practices. Construction industry is also must go for the green supply chain management. So what is the green supply chain management? Green supply chain management is the same as a conventional supply chain, which includes the planning, sourcing, manufacturing, delivering, but it also helps to reduce the resource consumption, minimize waste generation, lower the greenhouse gas emission, which eventually improve the overall environment performance. Basically, we integrate the sustainability into the supply chain management, but improve the environmental performance without compromising the operational efficiency is task, because there is a trade-off. We need to manage economical aspects of the supply chain, also the environmental aspects of the supply chain. There are existing methods which evaluate the best strategy, which can provide the best solution for this, like life cycle assessment, multi-criteria decision making, and other KPI based approaches. But still, they are lacking in something. Like life cycle assessment only focusing on the environmental aspects, but we require the balance. So to get that balance, a decision support framework for objective evaluating and benchmarking the relative efficiency of their GSCM strategies I developed. So now moving towards the methodology. First is the parameter identification. I need to identify the parameter which affects the supply chain, not only the efficiency aspects, but also the environmental, economical, and their other aspects also. So based on this parameter, ranges are fixed for those parameters and the scenarios are developed. These scenarios are then analyzed through the DEA model, Data Envelopment Analysis, and then the efficiency evaluation is done based on the DEA. So now moving toward the first stage, literature review and parameter identification. These are done by the Prisma analysis, and three categories of parameters are identified: economic, environmental, and operational. And then scenarios are developed. To develop the scenarios, parameters ranges are need to summarize from the literature. Minimum, mid, and max levels are decided. These are the 81 scenario. Different combinations are formed. Then the DA model. DA is a data envelopment analysis, is a non-parametric benchmark technique which is used here. For that, different inputs are considered. Inputs are minimizable, like production cost, transportation cost, carbon cost, and CO2 emissions for the production and transportation, as well as material wastage. I consider here only one single maximizing our output net profit, but based on the project requirement and client requirement, we can change the different number of inputs and number of outputs. Then this model is tested into the DA model, VRS I assumed, and based on that, these results are here. So these results are into the three categories, because I have three sets of parameter levels. S1 to S2 gives the 0.72 range of the efficiency. Second group is efficient up to the 0.88, and third is the most efficient group, which shows the efficiency of the one. As first group is showing lesser efficiency, it have the scope of to improve their environmental as well as other aspects of their operations. So what is the conclusion? This DA is already established, but we can use this model, this framework, to know the which scenario or which strategy is helpful to know to make our supply chain more greener, environmentally efficient, as well as operationally also efficient. So the practical contribution, so who can use this framework? Policymakers, contractors, or who is responsible for the planning of the all the resources specifically for the material, they can use this. And also who want to start the green supply chain management into their domain or for their projects, they can use this and got to know about their strategies, which strategy is working best for them. And for the future scope, there is a dynamic aspects I need to give with the multiple outputs DA model I can use. As I only used one output model, and then the demand uncertainty also I need to include. These are the references. Thank you.